Good evening. So today we will choose another dataset from the cargo and using the Julia language to analyze them. So this is the dataset page. I will put this link down at the comments. So we can see from here, there are multiple columns: destination, start date, end date. The introduction for all variables are here. So pause if you like. Okay, let's get started now. Firstly, let's open the Julia, and the packages that we will be using will be in-memory datasets. Okay, so for the first one, in-memory datasets, this is the one that we have used before, is to manipulate data, and DLM reader is used to write and read abstract dataset types. The graph package we will use is statistical graphics. Now we grab our data using import downloads. So the data for the data link we will use is this one. I will also put this link down at the comment. Okay, now we have successfully downloaded the data into our computer. We will use the file reader to read it into the new variable. Let's call it data. So by default, the DLM reader package assumes strings are not quoted. So if they are quoted, the user must pass the quote character by the quote car keyword argument. As we can see from the original data here, the destination, some of the destinations, it's quoted. For this one, we need to transfer the third and fourth column into the standard date format, because from our data, we can see it's like this. And we will change it to something like this. And now we can see for this column, the name is not correct. So we can use rename function to rename the first column as trip ID. Okay, we have done that. The next step is we want to get rid some of the missing rows. As we inspect from here, so the 72 rows, it's empty. And there are some other rows, which is 128 rows is empty. Therefore, we can use drop missing to solve that problem. Let's see the original data again. For the accommodation cost column and transportation cost column, some data have the $sign like this, and some of the data have comma in between, like this one. And some of them have USD. So we need to put them in same format. The function that we are going to use will be byrow function to parse every row and replace all the $sign, USD, and the comma. Okay, so we have already done that now, and we need to do the same for the transportation cost, which is the 13th column. We can use the select function to check that if we done it correctly. So for the select function here, it doesn't change the original data. It will be just a copy. So if we want to change the data set, we can go with over here, we can add the exclamation mark. Therefore, we can change the data set. But here, I don't really want this data to be changed. I just want to check if I done this one correctly. So let's see. Okay, so all the format has become the same. So let's continue. Let's see the original data again. For the destination column, I want to split the destinations into two parts, city and country. Just make our further analysis become easier. So what I do is to make a function for regular expression, which has two capture groups enclosed in parentheses. Let's say split comma pair. And we will use tuple with match. So for the first part, the first capture group, this one will match one or more non-comma characters. So this one add symbol here, it actually means one or more. And after this group, it will optionally matches a comma. Therefore, we go with this. And 0 or more spaces. Therefore, we add a space. And we get into the next capture group, which matches everything else remaining. The function that we will use with this regular expression will be modified. So for the step here, when tuple and split comma pair are functions, so writing like this with this one, it actually creates a new callable object that takes the same arguments as the split comma pair function and passes the value returned by calling split comma pair to the tuple function. So this operation is called function composition. So you can just type, so here you can just type CIRC with tab, and this will come out. And we want the destination column into a column named city and country. Let's see the content function. So the content function actually shows when the dataset has been created and when is the last time that it has been modified. It will also report the data type and formats of each variable. So now we can see the city column and country column has been added. We can use the select function to track again. Okay. Next step is I want to make the country column, such as USA over here, to become United States. So this link is really helpful. This one. This is talking about the country codes and country names with Alpha 2 code and Alpha 3 code. So all the countries' standard ISO code is all at this link. And these information are stored in Julia by countries package. Therefore, we will using that. Let's name a new variable, which is called account, to store all the information. Okay, so this is the country's package information. We can see for the Alpha 3 column, all codes are uppercase. Therefore, we need to make our country also to be uppercase, so we can easy to do the left join function. The function we will use will be still the modify. Okay, now let's use the left join function to combine the country names based on the column that country codes. Let's see the content of this new data set. Okay, so let's see using the select to see the another half of the function. Remember, we're using the select here just to see the copy. Okay, so here is what we need to do next. For example, USA. If the name column that is not missing, then we want the name, which is United States, to replace the USA, same as here. So this function will be really useful. Let me introduce the by row course. For this function, Julia actually has explanations for that. It will return the first value in each row of the columns, which is not equal to missing. If any, otherwise return missing. So let's say if we go backwards, if we say we're going from name to the country, so the function will return the first one that is not missing. For example, for this top 5, for the first one, it will return UK. For the second one, Thailand, Indonesia, but over here, the first not missing one will be United States. And that's how we change the country name. Okay, so here is the result. And finally, we want to change the country name back into the lowercase. Let's check using the select function again to see if we have done it correct. Okay, so we have done it successfully. But this method is actually having some restrictions. For example, for this country, UK, we know it's United Kingdom, but for the standard ISO code, it's GB as Great Britain. Therefore, we cannot change that by using the method that we just did. Okay, so let's use the content to see the final structure. Then we can rename the column just to make our life easier. Okay, so now we have done with the data cleaning and we can start the analysis. So for the first question, it will be which age have the most varies on the accommodation cost? So to answer this question, first we need to decide what kind of plot we need to make. So I think the box plot is the most fit one. So let's try a simple plot first. The package that we will use is statistical graphics. So it will be the SG plot. The dataset is CCN, and we want it to become the box plot. For y-axis is the accommodation cost, and we want the category variable as age. So this is what we get. And we can actually add some details on the code, such as outliers, outlier symbol size, or group color model, whites. So let's see. Okay, so after we have add the details, it will become like this. So for the second question, on average, which gender spend more on which accommodation type? So to answer this question, we need to make a data set in every accommodation type for each gender. So the function that I'm going to use will be combine. I want to group the CCN dataset with echo type and gender. If you write code like this, you can combine the accommodation type with gender and their mean accommodation cost. So IMD mean is a way to tell Julia to compute average value. Also, we can draw the box plot to see different gender spends on each accommodation type. We can actually use the code that we have used before. So the things that we have changed here is first we group by the CCN dataset by the accommodation type, and we change the category to gender. Then we change the whites to 100, and we wanted layout, which is represented by row. So let's see the final outcome. So it'll be like this. Next question is they want us to make some analysis on traveler age. So I think we can go with plot and explanatory analysis. So for example, we can still use the box plot over here. We can change this one as age. and rest remains the same. All right, and we can also make an analysis on some of the data sets. The function will be still the combine. To write like this, you get in-memory data sets with the average value, the minimum value, and maximum value. So which is showed over here, and we combine it with gender. Then we can make our conclusions. So comparisons between the box plot and explanatory analysis. The travel age between male and female are actually quite similar. However, male have wider range on age, but there are some outliers also present in the female's plot. All right. So the next question is, what is the top 5 most frequent visited countries and cities? So for this question, we will using the chain package. So for the chain package, remember it's got begin, and we will first gather by the country. So in here, we count the country appearance in the data set and store the value in the count column. And here we're using the sort function. So we can sort the count column and using the REV equal true. So it will sort from the largest number to smallest number. And don't forget, we have to put an and over here as it corresponds to the begin. For cities, we can do the same. Unfortunately, there are some data that is missing with the country. So actually, there's nothing we can do. For the 5 most visited country is Japan, France, Australia, United States, and Indonesia. And for the 5 most visited city is Paris, Bali, Tokyo, Sydney, and New York. Okay, next question. Which month is people prefer to travel? So to answer this question, we first need to get the month travel for every person, then count for each month's appearance. So here we change the format of the start column, which presents the month from each start date. Then we do the combine and sort like we did it before. So from the result, August and September are the most preferred months to travel. Next question. Find the least accommodation cost city on average, stored in a variable named cost and represented by kernel density and normal distribution. Okay, so we define a variable which is cost, and we will using the combine function again. Okay, so this step is easy. We combine the city with their main accommodation cost, and we can draw the graph by using the histogram kernel density. The x-axis will be the mean accommodation cost with both histogram and density plot. The y-axis, of course, will be the PDF value. Rest can remain the same. So not surprisingly, most accommodation cost is around 1,000. Next question is to investigate top 5 ways to travel. Let's set a variable, which is called trend type. So these steps are actually similar as before. So the most travel way is plane. And we can also use the pie chart to represent it. The category will be trace type, and we want them showed depends on the count column. So depends on this column. And we will label it with percentage, and we want it to be rotate. So the inner radius is actually deciding how big the circle in the middle will be, and the width and height is just deciding how big the whole graph will be. Okay, so this is what we got. We can do the same for accommodation types. Let's say I want to express age and accommodation cost by different accommodation type. So I will use, for example, scatter plot. So this is what we have got. We use the scatter plot. Here we replace the group with color response just to make the graph clear. And we can do the same for the transportation type. Here we add the symbol response. So we can represent the different transportation type with some funny symbols. Yeah, just like that. Okay, and the next question is require us to investigate the relation between traveler age and their traveler durations. So I think for this one, scatter plot again. So we can see most people is actually centered about 7 days. Next question is to investigate the relation between accommodation cost and duration with gender. We can use the code that we have used before. Okay, so we just need to change some details. For example, the y-axis will be accommodation cost, and we want it with a color response to be the gender. So it will be like that. And for the final question, it's asking us to investigate trip durations by traveler gender and nationality. So I think the bar chart is actually the most suitable one. So here we put the y-axis become the nationality with responses of the duration, but the duration will be the mean because I use the IMD mean here. So it will return the mean of the duration, and we want it separate the group by gender commute. All right, so this is the final graph that we get. Actually, there are some restrictions. The problem with the original data, for example, over here it's UK, but over here it's United Kingdom. So this is the problem with the original data, and we can't really solve this problem by just using the code. Okay, so that's about it for analyze this traveler dataset. And I will put those important links down at the comments. Thanks for watching.